morning, afternoon, evening, and night to everyone, depending on where you are. Thank you so much for joining today's webinar. My name is Xiaogang He. I will be the moderator for our session today. This is the first time for me to moderate a climate conversation, and it's so great that we can do this in a low carbon and climate friendly way. First of all, let me have a quick introduction of myself. I'm an assistant professor in civil and environmental engineering at the National University of Singapore. I'm also an affiliated faculty member of the Center for Nature-Based Climate Solutions at the university. I'm a hydrologist by training, and my research focuses on how climate change, climate variability, and human interventions affect hydrological extreme events, including floods and droughts, and how to implement integrated approaches to reduce their societal impacts on the interconnected water, food, energy sectors. In the wake of a changing climate is a 4-part monthly panel discussion series jointly organized by the HEAD Foundation and the Center for Nature-Based Climate Solutions. Today's webinar is our second in a series on the water, food, energy nexus in the context of a changing climate. In today's webinar, we will dive deeper into the water dimension of the water, energy, food nexus to identify where the current and future water-related challenges are and the solutions for more effective water governance and management. First of all, let me quickly introduce the two organizations that support this webinar series. The HEAD Foundation was established in 2013. Its goal is to help improve the lives of people in Asia by disseminating knowledge and sharing ideas, and by supporting and funding sustainable education and healthcare projects that develop social and human capital. The Center for Nature-Based Climate Solutions was established last year. The center is a focal point for research, thought leadership, and education on nature-based solutions on climate change mitigation and adaptation. It produces policy relevant science, builds capacity in the public, private, and people sectors to help achieve a carbon neutral and stable global climate. In today's webinar, I'm super excited to talk to 3 world leading scientists and policy experts on climate change and water security. Our 3 panelists are Dr. Peter Gleick, Dr. Cecilia Tautalhada, and Professor Kuting Chai. I should mention that it's late night, 10 p.m. for Dr. Gleick, and it's early morning, 6 a.m. for Dr. Cecilia. So thank you very much for your flexibility and your precious time. Okay, let me go through a few housekeeping issues. In today's webinar, each panelist will be speaking for about 15 minutes. And after all of their presentations, we will have about 15 minutes panel discussions among the panelists. This will be followed by a 15-minute Q&A session with the audience. Your microphones will be muted throughout the session. If you want to participate in the discussion, please enter your questions into the Q&A box. Everyone in the audience will be able to see these questions, and you are also able to vote for the questions that you would like the panel to address. You can vote by clicking the thumbs up button, and we will prioritize the questions according to the vote. And we will wait until all 3 speakers have given their presentations before we start our discussion. Sounds good? Okay, great. Before I introduce the first speaker, let me give you a quick introduction of the Climate Change and Water Security 101. Let me put up my slides and share my screen with you. So water is one of the most important resources for humankind, but only 2.5% of the water on Earth is fresh water. About 70% of that is stored in ice, and 30% in groundwater systems, and only 0.3% is directly available in rivers and lakes. Unfortunately, climate change and human activities are changing the composition of water on Earth. For example, in a warming climate, snow melt runoff will be changed in timing and the peak volume. Water supplies stored in glaciers and the snow cover are projected to decline. And the consequence is we will face sea level rise. Water temperature in rivers and lakes will also increase, and this will affect water quality and ecosystem services. When we talk about water security, it's related to 3 water-related challenges: flood risk, too much water, drought risk, too little water, and water pollution, dirty water. In the coming decades, these challenges and their impact on people's daily lives are expected to increase due to population growth, economic development, increased agricultural production, and climate change. So each year, water-related disasters such as droughts and floods affect approximately 160 million people. Flooding affects most of these people, and it's about 106 million every year. Unfortunately, due to improved early warning systems and increased disaster management capacity, which my research focuses on, the number of people killed by weather-related disasters has decreased over the last decades. However, as you can see, the annual number of people that die from inadequate water and sanitation is extremely high. In terms of economic damage, floods cause the largest damage, about $30 billion every year. Climate change has already and will further intensify the water cycle. This map shows the change in net precipitation between 2010 and 2050. There are a lot of things going on here, but in general, the net result of climate change is that most dry areas will become drier and wet areas will become wetter. In addition to the mean shift, climate change will also amplify the risk of extreme events. What I'm showing you here is the flood frequency by the end of this century. Blue color means increasing trend, and red color means a decreasing trend. We can see that there will be a large increase in flood frequency in Southeast Asia, Africa, and South America, but it will decrease across large areas of Europe. In the drought side, we can see that there are robust projections of increases in the 12-month drought duration in Southwest US, South Africa, and many other regions. Changes in these extreme events due to climate change imply major risks for society, not only directly through alterations in the hydrometeorological processes that govern the water cycle, but also indirectly related to through risks for energy production, food security, economic development, social inequities, regional conflicts, among others. So in today's webinar, our 3 panelists will talk more about water-related challenges and solutions related to these topics. Okay, great. That's water security and climate change 101. Now is the time to introduce our first panelist, Dr. Peter Gleick. Dr. Gleick is co-founder and President Emeritus of Pacific Institute in California. Dr. Gleick is one of the world's leading experts on freshwater resources, a hydroclimatologist focused on climate change, water, and conflict, and the human right to water. Dr. Gleick's work is used by the United Nations and in human rights court cases. He has worked extensively on issues related to water and international security. He is a MacArthur Fellow, member of the US National Academy of Sciences, and a winner of 2018 Carl Sagan Prize for Science Popularization. Without further ado, let me welcome Dr. Gleick to speak to us.
Well, thank you very much, Professor He, and welcome to all the participants. As was said at the beginning, good morning or good afternoon or good evening, as is the case for me. I would like to talk about what I see as a coming transition to freshwater sustainability, both the need for that transition and what I believe, in fact, is a transition that's happening right now toward more sustainable freshwater resources. I will also share my screen. Let me start first by giving a short summary of what I'm going to say. I believe we're in a transition to freshwater sustainability from today's era of unsustainable freshwater management and use. That's the good news. I think the shift will be slow from where we are today to where we want to be. I acknowledge right up front that bad things may happen between where we are today and where we want to be. And I would note that climate change is a very significant and complicating factor in that transition. I would also argue that we can and must do what we can to accelerate that shift away from the practices of yesterday and today toward more sustainability. So why do we need a freshwater transition? Well, I would simply say we have a freshwater crisis. There are many aspects of the freshwater crisis. We know, for example, that one of the most significant is the failure to provide safe water and sanitation for hundreds of millions, if not billions of people worldwide. We know that natural ecosystems are suffering from human withdrawal of water. We know that there are water quality problems from human wastes, from industrial wastes. We still have extensive water-related diseases that are associated with the failure to provide safe water, drinking water, and adequate sanitation for the world's population. There's a growing trend in conflict, violent conflict over fresh water resources, and I'll talk a little bit more about that. And of course, climate change, which, as Professor He mentioned, is a very significant factor for water resources, and I will address that in particular as well. We know that humans are changing the climate. This is a graph of the global temperature over the last 1,000 years, based on both the instrumental record and the paleoclimatic record. And it shows in red toward the right side of the graph, the very rapid and extensive increase in global temperature as a result of human-caused climate change, the direct result of human emissions of greenhouse gases. This is a graph that basically shows the same thing, but just for the last century, from the 1800s, 1880s up until the present, that shows the global average temperature compared with the average temperature of the middle of the 20th century, again, showing the very rapid and dramatic increase in recent decades as a result of human-caused climate change. And the impacts of climate change will be many. We know that ice is melting, as again, Professor He mentioned in his introduction. We're losing glaciers, we're losing ice from Greenland, we're losing ice from Antarctica, and the Arctic itself is disappearing very rapidly, ironically, far more rapidly than even the worst projections of the climate models. We know that higher temperatures will worsen droughts and increase the frequency of forest fires, a problem we're already experiencing here in the western part of North America and has been experienced in Siberia and other parts of the planet in recent years. We know that we're going to see more extreme storms, hurricanes, typhoons, more extreme rainfall events, more extreme droughts. We know that rising seas are going to cause coastal flooding. We're already seeing sea level rise, and increasing temperatures in the ocean and increasing acidification of the ocean is damaging coral reefs. And of course, there will be very significant impacts on agriculture. Agriculture is very sensitive to temperature, it's sensitive to water availability, it's sensitive to all of the things that climate will be affecting. So one particular aspect of this is political crises over water resources. And I know that we will have another panelist talk about that shortly, but let me talk about one aspect of this. One of the things that my institute, the Pacific Institute, does is we maintain an open source database of conflicts associated with water resources. It's called the Water Conflict Chronology. You can see the URL here if you're interested in more information about this. But there are over 1,000 examples going back almost 4,000 years of conflicts associated with water resources, where water was a trigger of conflict, or where water resources were used as weapons during conflicts, or where water or water systems were targets or casualties of conflicts. And this graph from 1930 up until a couple of years ago shows the very dramatic increase in the number of water conflict events that have occurred worldwide in recent years. And that's a cause for worry, and it's a result of increasing tensions over access to and control of fresh water resources. I would argue that Southeast Asia is especially vulnerable. We have high populations, there are growing economies and demand for water. There's extensive internationally shared water resources in the region. There's extreme vulnerability in the region to climate change from water scarcity, from sea level rise, from extreme events such as changes in the monsoons. And there are already political tensions over water, even without climate change, both at the subnational level over scarcity and access and control of water resources, between cities and farms, between ethnic groups, but also transnationally when water crosses borders, as so much of the water resources of Southeast Asia do. Many of the rivers, in fact, almost all of the rivers, I would argue, are shared by 2 or more countries. And drought and water scarcity are expanding. So what can we do about the climate piece of this? Well, first of all, we know we have to cut emissions of greenhouse gases. We have to mitigate the emissions. There's a very important water component here, the energy-water nexus, which is part of this series, where water is required to produce and use and move and treat water. It turns out a tremendous amount of energy is required to provide the water and the water services that we need. And as we burn energy to produce the water services and water benefits that we want, we also emit greenhouse gases. And so smart water policies will integrate these factors. Smart water policies will not only reduce our tensions over water resources, but will cut emissions of greenhouse gases associated with our water needs as well. So cutting emissions is one of the key strategies. But we also know that we have to adapt to what are now unavoidable impacts of climate change. That includes impacts on water resources, impacts on water availability, impacts on water quality. Any move we make toward more sustainable water management and use will help us in adapting to the now unavoidable consequences of climate change. Changes in water availability, changes in water quality, changes in access. And so we have to both mitigate greenhouse gas emissions and adapt to those consequences of climate change that we can no longer avoid. So where does this lead us? I would like to argue that we need a new path for water, what I call a soft path for water. When I said at the beginning that I think we're in a transition to a new path for water, this is really what I mean. And let me describe what I mean by a soft path for water. And let me contrast that with what I call the hard path being the strategies, the technologies, the institutions that we used in the 20th century to address our water challenges. And let's think about this in a couple of ways. In the hard path, the idea was build for water supply, find more water, build more dams, build more aqueducts, drill more groundwater wells, find more water supply, and expand the access to water that's available to us. The soft path says we need to rethink supply. We need more supply in many regions, but we have to think about different forms of supply. We have to think, for example, about highly treated wastewater as an asset, not a liability, as we're seeing has been done in Singapore and is being done elsewhere. That expands our supply without taking more water from natural ecosystems, without overtapping groundwater, without draining our rivers dry. New supply may mean desalination if we can spend the money and address the environmental impacts associated with that. But if we rethink supply, a whole new set of options become available to us. The hard path said satisfy projected demand for water. And projected demand for water was that demand would always increase no matter what, as our populations grew and as our economies grew. But the soft path says rethink demand. Let's think about how to do what we want with less water. That's the concept of water conservation and water efficiency. Grow more food with less water. build the industrial capacity and meet our industrial demand more efficiently, meet our household water needs more efficiently. And in fact, in many parts of the world now, we're actually able to reduce the demand for water without decreasing the benefits that water provides us. So the hard path said, satisfy some projected demand. The soft path said, rethink demand and make demand management a fundamental part of a 21st century solution. The hard path said water is an economic good. The soft path says water is an economic good and a human right. And let's address both of those together. Let's price water properly. Let's meet basic human needs for water when they can't be met because of reasons of poverty as a human right and provide those water services for free if we need to. Let's think about smart subsidies, not bad subsidies for water. The hard path says, let's build centralized water treatment and produce one water quality, that is potable water. The soft path says, first of all, protect source water quality so that we have to treat water less than we would have, but then let's match the quality of supply to the quality of the water we need. Not everything we need to do requires potable water, for example. Let's get smarter about matching the quality of the different supplies that we have to the quality of need. The hard path gave no thought to ecosystems. Either we didn't know or we didn't care in the 20th century about the ecological consequences of our water policies. Those days are over, or they ought to be over. And the soft path says, protect ecosystem needs, protect ecosystem health as a fundamental part of water systems in the 21st century. And last of all, the hard path had centralized management and limited participation, public participation in certain kinds of centralized institutions. And the soft path says, let's expand that. Let's have community participation and decision-making around water resources. Let's have flexible water institutions. Let's have more integrated water institutions so that we think about energy and water together. Let's have our energy utilities and our water utilities work together. This is the difference between the hard path and the soft path. I think we're already on the soft path, but we need to do things faster, more aggressively, and more successfully worldwide. But there are examples of these kinds of soft path policies everywhere around the world. Let's look and see what's successful. Let's build to scale. Let's expand the successful strategies worldwide. So in summary, I believe a major transition is needed in the way we think about and manage fresh water. I think such a transition is underway. Many factors influence the need for resource transitions. There are politics, there's economics, there's technology. All of those factors need to be addressed as we move toward more sustainable water resources. Those factors will affect the speed and the effectiveness of resource transition, and understanding the different factors can help us accelerate the needed changes or influence the direction of such changes. And that requires better institutions. It requires individual action and institutional action. It requires new technology, but better application of old technology. And if we bring those things together, I think we can move toward a soft path for water much more quickly and much more effectively. Thank you very much.
Thank you so much, Dr. Gleick, for the thought-provoking presentation. We will hold out the discussion until all the three speakers have finished their presentations. For the audience, please do type your questions in the Q&A box. Okay, great. Let's move on to our second speaker, Dr. Cecilia Totahada. Dr. Cecilia is a professor in practice in School of Interdisciplinary Studies at the University of Glasgow. Dr. Cecilia's work mainly focuses on the impacts of global events on water resources, societies, and the environment. She has been an advisor to major international institutions and has worked globally on resources and environment-related policies. She is a member of the OECD Initiative on Water Governance and is a past president and honorary member of the International Water Resources Association. With that, I will hand over the floor to Dr. Cecilia.
Thank you, Xiaogang. Good morning from Glasgow to everybody. Thank you for the invitation to speak today and share this place with so distinguished speakers. So I will be speaking on water governance and what are the implications in this area of climate change that Peter already explained. So this water security that was so well explained by Xiaogang at the beginning is about availability, access, affordability of clean water, but is for all users and for all users, which have been increasing in number and in type. If we see the water security concept, the water security problem within the framework of megatrends or global shift or long-term developments that are the drivers of change, and we think how this water security is changing, has been changing because of economic development. We are growing, we need more water. Population growth, urbanization, and now climate change, that in terms of water, it reflects in terms of floods and droughts. We see that water is scarce and pollution, and that this availability, access, and affordability I mentioned is just at risk. We don't have enough water for all the users. So let's go to water governance. Water governance is defined in different ways. I chose the definition by the OECD because it's very comprehensive. And it's basically about decision making. It's this range of political, institutional, administrative routes, practices and processes, stakeholders, interests, and so wants and needs, that their concerns are considered, and many times when they are completely opposite, and the fact that decision makers are and should be held accountable for water management, except not only decision makers, but every sector of society. So water governance is very complex because it includes interests from different sectors and needs from different sectors. So how does this look in Asia? In Asia, we have about 1.8 billion people living. They depend on 10 rivers for water is already scarce and polluted, where we have large centers, the largest centers of population, highest population growth also, where most of the bodies of water are transboundary. And as Peter already explained, decision making is each one of the countries look for their own interests, except the more downstream you are, the more affected you will be. So what is it, the challenges we are facing? Poor decision making, institutions that don't have the capacity to take the task, and now again, the climate change while we continue growing. So if we talk about the water risk, this is considering trillions of dollars. What does this mean? This means that because of poor decision making, because institutions are not able to, and they don't have the capacity to take decisions. And in addition, with climate change, we are going to have all the assets affected, from infrastructure to the natural infrastructure. It's not only the gray, but the green and also the digital infrastructure that is being affected. Now let's take a closer look to Asia. This is Asia. These are our centers of population that, as we can see, are highly populated. And these are the areas where our water is polluted and is scarce. Is water the only resource? It's not. Is it the most important? Well, one would argue it is because it affects every other sector. However, decisions on water are not taken necessarily are not given priority unless there are droughts or floods, and then the interest disappears. And to this, we add this increasing number of natural disasters and that are not that natural, and extreme weather events. We see that most of them are in terms of floods. And if we see all the way to the bottom, we see the droughts. But as we are going to see in the next slide, this number of droughts and number of floods, they are affecting an increasing number of people. This is where we see the number of people that is being increasingly affected, and it is in the number of millions. There are places, and I will mention some brief examples, where the governments are prepared. This has become a race. Our resources, natural resources are scarce, are polluted, are degraded. We have more people, we have more needs, and we have not developed the capacity. And in addition, now we have more droughts and more floods. Disease, we have events that are disturbing, further disturbing our systems. Now, in terms of water risk, and coming closer to Southeast Asia, I'm going to present very briefly what the Aqueduct says. Aqueduct is part of the World Resources Institute, and they talk about water risk all over the world, based on quantity of water, quality, but also these regulatory aspects we have been mentioning, and also the reputational risk. What we see, and these are 3 slides that show what Aqueduct says about Southeast Asia in the 2020s, and this is showing water security, but water security is not only natural, but this is man-made. The pollution is due to, again, poor management decisions, and the scarcity is because we are not using the resources properly, we are not treating them, we are not discharging them properly, and this is affecting populations. If we see the next slide, we will see that in 2030, the water insecurity increases. And if we go to the next slide, we will see that in 2040, the situation has become much worse. So are we taking decisions according to the changes we are living? And the answer is no. In the case of Southeast Asia, it's only Singapore, the one that is going ahead of time. The rest of the countries are just going very well behind time, as it is the case in most of the developing world. I am going to present very quickly what the American Meteorological Society says, where they have a very good annual publication, where the different authors try to explain extreme events from a climate perspective, and more important, what is being the impact in the world. And as you can see, it's not only droughts or floods, but it's all type of events. We will see that in 2000, well, this was the 2016 publication, but if we go to the next slide. But let me mention this very briefly. Mr. Ku is going to speak with all his wealth of knowledge on Singapore. But in 2014, what this publication presents is 3 events that are very important. One is the 2014 record dry spell in Singapore, about 50 days with less than 1 millimeter of water. This was not of rainfall, I'm sorry. This was not the first time it happened. It just happened for longer days, 62 days, I'm sorry. We have dry spells in 2005, 2009, and then in 2014, except Singapore is prepared. But this is something Mr. Ku will talk about. I will mention the floods in Jakarta. Jakarta, because Jakarta has numerous problems in terms of water supply, sanitation, in general, in terms of water governance. And these extreme events, they exacerbate the problems that already existed. So we see hundreds of thousands of losses, millions of dollars in losses. But these losses were in that moment. How many of those, how much of that situation has been improved? And it is unlikely to have been improved. Things have become only more difficult. The California drought is important because it can affect the entire world. 2011, 2016, there was a California drought where almost half of the state was in the most severe drought category, considered as exceptional at that time, except now they are in the middle of a more severe drought. So this is what happened in Singapore, but I won't mention it again. This is Mr. Ku's presentation. If we go to the next presentation, this is the California drought. So between, as I mentioned, 2011, 2016, this was considered the driest period since 1895, except between 1895 and now, population has increased by millions of people. It has been the most severe drought in the last 1,200 years because of variability of precipitation and also because of record high temperatures. But remember, this was before the current drought that is even more severe. And why is it important for us, for example, I still count myself in Singapore. Why is it important for Singapore if we go, or the rest of the world? If we go to the next slide, we will see that we did a study on how this had affected food security. There were many losses, but the government stepped in. That is the difference. In many places, the government, the institutions don't have the capacity. State of California, government of the United States, they have the capacity. So what we saw was that those agricultural produce, those fruits that are the most important for the state, for the farmers were able, I mean, they decided to invest so much in order to continue the production because it will be, because it was profitable for them, because they already had the almonds. You cannot take out almond trees because they are years of investments, which is what is happening now in California. Why is this important in Singapore? Because Singapore imports 90% of the food that it consumes. So decisions, good decisions or bad decisions in the places where the food that is going to be transported to Singapore, that should be, we should be interested on those decisions. What is happening in the world that can affect us? So it's not only the climate change, but it's the change in decision making, the one we should be paying attention to. So California and the farmers were able to go through the drought because they have good government, but because they have groundwater. However, if we see, as there have been droughts and as farming has become more intense, groundwater level has been decreasing. How long this is going to last? And this is where not only water governance, but economic development, livelihoods of farmers. This is what has to be considered for this law, the groundwater management law that will come in effect in several decades from now. So let me come back to water governance. So this water governance is a series of political, institutional, and administrative rules, practices, and processes, stakeholders, and sectors. It's very important. We still don't know how to do this, how to do the trade-offs, how institutions, even within the water sector, can take a series of policy decisions that are, if not a win-win situation for each one of them, that they are, that they represent a win situation in general, even if some of the institutions have to lose in that moment. But we have to look for development, for overall development, which is what we are not doing in terms of the water governance, in terms of the water decisions. And with this, I finish my presentation. Thank you again.
Thanks a lot, Dr. Cecilia, for the presentation. Our third panelist today is Professor Ku Ting Chai. Professor Ku is a professor in practice in the Faculty of Engineering and the School of Design and Environment at the National University of Singapore. Professor Ku was the executive director for the Center for Livable Cities, and he continues to be a fellow there. He was formerly the CEO at the Urban Redevelopment Authority and chief executive of Public Utilities Board, Singapore's national water agency. He sits on the boards of NUS, Tropical Marine Science Institute, and Institute of Real Estate and Urban Studies. He was awarded Meritorious Service Medal in 2018. Without further ado, let me welcome Professor Ku to speak to us.
Thank you, Xiaokang. I think we all know that Southeast Asia is urbanizing rapidly. It has some of the biggest megacities in the world, cities like Bangkok, Jakarta, Manila, and Ho Chi Minh, right? More than 10 million. Right? In fact, if you include the metropolitan areas, there are probably more than 15 million. And they are all in the wet tropical climate zone, and they are coastal or riverine cities, right? And for these cities in Southeast Asia, as the previous speakers have alluded to, water is both a boon as well as a bane for urban Southeast Asia. I'm going to talk about urban Southeast Asia because that's what I'm more familiar with, right? And freshwater supply, especially as Cecilia has touched on, is a challenge for the city's huge population and industrial needs. But intense rain from tropical thunderstorms and the monsoon season also lead to sometimes, catastrophic urban flooding events. And at the other extreme, the cities do suffer droughts. And in a wet area like Southeast Asia, as Cecilia has mentioned in her slides, a drought is, you have a dry season that's more than a month, 40 days, 50 days. That's already a very severe drought, right? And these weather phenomena are likely to increase and will be compounded with climate change. So how are these cities going to manage these very, very serious challenges posed by climate change? So allow me to use Singapore as a case study. Now, we are an island city-state at the equator, lots of rain. In fact, on average, 2.4 meters of rain a year. But yet we were, in the 50s and 60s, a water-stressed city-state. We had a population of less than 2 million in the early cities, and the city was overcrowded with slums in the city. We had droughts, we had floods, we had polluted rivers, as shown in this slide. Now, today, our population has actually tripled to 5.7 million. We are much more livable, even though the density is so much higher. We are now quite livable, quite sustainable, and quite resilient with water sustainability, little flooding, clean rivers relatively, right? But the challenges that Singapore face really are not very different from those faced by many rapidly growing developing cities in Southeast Asia and elsewhere. So perhaps how we solved our water problem could have some relevance to other cities, especially rapidly growing cities in the tropical or equatorial area. Now, how did we solve our water problem? Now, we took a systems approach, right? And I can sum that systems approach in just 6 simple words: water for all, conserve, value, enjoy. And I'll just very quickly elaborate on this. Now, water for all is all about ensuring that we have enough water by diversifying our water supply sources with what we call the 4 national taps, right? Peter Gleick talked about rethinking supply. So we had no choice but to rethink our supply for decades, because we're an island. And as an island, we have competing uses for land. We need a lot of land for housing. And so we could not build enough reservoirs, and we had to buy water from Malaysia. But taking an integrated approach to try and harvest every drop of the 2.4 meters of rain that falls onto Singapore, what that means is that we have to make sure that water remains clean. So we have to create a separate sewage system, so separate the used water, the dirty water from the clean water, the rainwater. We have to have good urban planning to make sure that pollutive users like factories that discharge polluted water are separated from the water catchment areas, and good environmental management to make sure our rivers remain clean and not polluted. So today, in the very densely populated city, we have 17 reservoirs collecting water from 2/3 of Singapore, including the most urbanized areas like the Marina Reservoir, which collects water from 5 rivers, which flows through the city center and the outskirts. And the Marina Barrage actually serves as protection from flooding, as well as an iconic plaza, a water plaza for the city. So it's a kind of a 3-in-1, solution for the city. But we also looked at water as a renewable resource, right? Another way of thinking about water. And we try to short circuit, we try to close the water loop using technology, right? So that means that we short circuit the natural hydrologic cycle where water is used, that is used, get recycled naturally after being discharged into rivers and sea by rain bringing water back onto the lake and the reservoirs. So we short circuit that natural hydrologic cycle by using technology that treats used water with membranes that filter out even tiny viruses and dissolve solids, right, in polluted water. And we call the resulting recycled water new water, right? And this diagram, you don't have to worry about it. It's a very technical diagram that shows how membrane technology is used to really purify water. So the 4 national taps ensure that Singapore can have enough water to sustain us for a very long time to come. But on the other side, as Peter Gleick said, we also have to rethink how we use water, right? So water demand management, this is just a very one-slide summary of what we do in water management, but it includes policies to conserve water and reduce wastage, through right pricing, through minimizing losses through the water distribution network, the pipes, and through a lot of education and community engagement. So that's really treating water as a resource, as a renewable resource, closing the water loop, and using technology. But water, it's not just a resource. It's very important as a resource, but water infrastructure in the city or water in the city, rivers, canals, can be an ugly blight on the urban environment. So concrete canals, huge pipes. So water can be turned into a wonderful environmental asset for the city. So we have a program called the Active, Beautiful and Clean Waters, the ABC Waters program, launched in 2007, which we will try to make the 17 reservoirs I mentioned earlier, the 32 rivers, and the 8,000 kilometers of drains and canals to try and landscape them, beautify them, and really integrate them well into the very dense urban environment. So, for example, this park, Ang Mo Kio Bishan Park, was a park with a drain, ugly drain next to it. We've turned it now into a stream that meanders through the park. So, an example, of a nature-based solution. But with climate change, all that we have done is not enough. So with climate change, water will be an even more difficult challenge. Rising sea level, more droughts and floods. And the Prime Minister has warned that the nation needs to tackle this challenge. And we are facing it head on, led by the Prime Minister himself. There's an interministerial committee, and it has to be a whole of society effort of climate defense. And it is this kind of systems approach, a total holistic approach, that has helped Singapore achieve higher livability even as our density increase. And we've progressed from being a garden city, focusing on the greening, then focusing on the water, city of gardens and waters. And now, with more density, we are trying, nature-based solutions to be a city, in nature. And this is articulated, and the plan is actually been drawn up in the Singapore Green Plan 2030. That is the coordinated work of 5 ministries in Singapore. But equally important is really keeping our knowledge, increasing our knowledge, learning, researching on what's going to happen with climate change and what are sustainable, resilient solutions. And so a lot of climate research is being undertaken. We're trying to learn from as many countries and cities in the world, especially the Dutch, who are very experienced in some of these things. And what we are trying to find out specifically is what is the impact of climate change in our region, in Southeast Asia. And then we have to find creative solutions like nature-based solutions. So some of the research effort, by centers, some of them are shown in this slide at the universities as well as national centers. Now, the question is the approach that Singapore takes applicable to other cities? The center that was heading, the Center for Livable Cities, was set up in 2008 to distill the principles of Singapore's approach to answer this question for Singapore, for our new generation of urban leaders who have to grapple, with climate change and other challenges. So this is the urban systems approach that I talk about, and the principles are captured in urban system studies, which are available on the CLC website and in this livability framework, right, which is explained also in a document that CLC has published. But what's the challenge for Southeast Asian cities? The NUS Deltaris, a partnership, recently did a satellite image study of Southeast Asia using LiDAR technology. And they found that more areas and people will be affected by flooding in Southeast Asian cities than previously thought. So how best can Southeast Asian cities share knowledge and experience and learn from one another? Now, when Singapore chaired the ASEAN a few years ago, it initiated the ASEAN Smart City Network, starting with 26 cities. I think the network has continued, probably by now, yes, more cities. And many of the challenges that the cities put forward where they wanted, smart solutions using technology were really water-related challenges. But the Smart City Network that was set up brought together national and local governments, international organizations, NGOs, and the private sector to find good solutions to the problems. Now, our approach, Singapore's approach, has been to learn from as many cities as we can. And we've been sharing freely our approach by organizing international forums like the Singapore International Water Week and the World City Summit, where more than 400 cities come together to learn and share best practices. And we also award the best cities with the Lee Kuan Yew Water Prize and the City Prize. But there are other international city networks like the C40, UCLG Aspect, United Cities and Local Governments Asia Pacific, and the Urban Land Institute. Climate change is really now a key focus area for these networks of city leaders, business people, professionals, and the community. So the Center for Livable Cities partnered ULI recently to look at how 5 cities from across the world are coping with climate resilience, and then distill these into 10 principles which will be useful for city policymakers, for the industry, and the community at large. So I hope these brief remarks show how a systems approach comprising good governance and integrated planning at the city, national, and regional level can help us to begin to systematically tackle the big challenges that water can pose to us with climate change. Thank you very much, and I must acknowledge that many of my slides are thanks to the PUB and the Center for Livable Cities. Thank you.
Thanks, Professor Koo, for the really insightful presentations on water, city, climate nexus. So before we start our panel discussion, I would like to remind and encourage all the audience to continue submitting your questions through the Q&A box. And please don't forget to vote for your favorite questions using the thumbs up button. And for the next 15 minutes, let's move on to our panel discussion part. Perhaps I can start with a question just to follow up on Professor Koo's presentations on Singapore's ABC Waters program, which uses very innovative approaches to transform and renaturalize Singapore's urban water systems. So the first question that I'm going to throw to Professor Koo, as well as the other 2 panelists, is can you please share with us some best practice examples of engineering-based or nature-based solutions that have been successfully implemented to tackle water security issues and mitigate climate change impacts? And what lessons have we learned? And looking forward, what are the implementation challenges in terms of infrastructure investment, water governance, and how should we address them?
Okay, can I start?
Yeah, please.
Okay, so ABC Waters actually did not start off being about climate change, right? As I showed in my presentation, it started off as a way to kind of ameliorate the problems of water being, something very ugly in the urban environment. But, we realized as we implemented it that, it is what Professor Peter Gleick called a soft approach, right? And in fact, the principles behind ABC waters is nature-based, but a lot of the principles are about, not having hard surfaces, making sure there's porosity, landscaping, so when you apply those principles, you are actually, in fact, trying to be more resilient to be able to withstand some of the extreme weather events. In fact, ABC waters is now incorporated as part of the principles that PUB has now adopted in its latest drainage code. Is embodied in a way in the source pathway receptacle approach that is now in the drainage code. And I think between PUB and people like me and I think the urban planners, we see ABC waters as something not to be done just by water engineers, but it should be done by urban planners, right? So for example, if you look at HDB towns, our towns, Pongo town, where they would have had a pipe between two rivers, they turned that pipe into a very beautiful waterway that now becomes a very fantastic waterfront feature for Pongo New Town. And I dare say it increases the property value, right? So nature-based solution actually brings about a lot of economic value as well.
Yeah.
If
So,
I can
go ahead, please.
Thank you. If I can continue, the great infrastructure, but infrastructure we know, was developed for many years, for centuries, because it's the only solution we have, only thing that humans need. And then it came this enlightenment, there should be nature-based solutions. But your question was, what have been these infrastructure development or nature-based solutions for water security, climate change mitigation? And the answer is none. You need a combination of all of them. You have large dams that have a purpose, but they also have many impacts. You have numerous nature-based solutions that are developed at a larger scale or small, depending on the area you have, but they also have a limitation. You have the sponge city concept that was started in China, is being used in many other places, and they have a limitation. So at the end, what we need is a combination, like Mr. Koo said, we need to learn from different places and we need to see what is more useful for us. One aspect or one of this infrastructure, the gray, the green, or the digital, is not going to help. You need a combination and you need to use them depending on the situation.
So Dr. Gleick, do you want to add anything else?
Sure, let me quickly just add two good examples of nature-based solutions. We're coming a little bit late to the question of nature-based solutions. We thought for a long time that nature wasn't important, and only now are we trying to think about how to integrate nature back into water management. But two quick examples. We grow a lot of rice in California, in Northern California. There's a fairly extensive good soils for rice. There's a lot of water at certain times of the year. We used to then drain those rice fields and burn off the rice husks in the winter, causing a very serious air quality problem. Today, we've learned that if we flood those rice fields in the winter, we can get rid of the rice husks, but at the same time, we're restoring natural wetlands. And California is actually also an excellent place for very, very large numbers of migrating birds. And in the winter, those flooded rice fields now provide habitat for literally hundreds of thousands of migrating birds. And that's an example of solving an air quality problem, a water problem, and an ecosystem problem. One other quick example is we're now beginning to realize that in order to address great overdraft of groundwater in California, if we flood some of our fields in the winter and capture more of our storm water, we can recharge groundwater. That's a benefit to agriculture in the dry season, but it also produces more stream flow in the dry season as groundwater levels go back up, and that provides an ecosystem benefit. So two quick examples of ways of integrating smart water management, smart groundwater management, and ecological protection.
Yeah, thanks, Dr. Gleick, for the great examples in terms of the multi-benefit, those kind of water management. And my next question to all three panelists is about extreme events. All of you have mentioned the extreme events in your presentation, and extreme events are also increasingly grabbing the headlines. For example, recent record-breaking heat waves and droughts in the American West, floods in Southeast Asian countries, hurricanes in the east coast of US, among many other places. And these extreme events are becoming more likely and intense due to climate change. And right now we are still in pandemic. What's worse is that the compounding impacts of COVID-19 and climate change have made the society even more difficult to function and recover. And the policymakers are highly concerned about how natural disasters and climate extremes are likely to intersect with the spread of the virus by increasing the public's exposure to infection and the COVID-19 response, especially that of hospitals and emergency services. So the overarching question is, what are the roles of our water infrastructures in driving the COVID-19 recovery, and what lessons can we learn from this pandemic to address future water and climate crises? Dr. Gleick, do you want to share your thoughts first?
Yeah, so first of all, I'm living in California right now. As Dr. Tortajada said, we're in a very extreme 2-year drought already. We don't know how long it will continue. This was following on the worst 5-year drought, as she described in the historical record. A quick example of that, obviously, many of you have read recently about the extreme heat waves, the fires that we're experiencing, the drought, all of which are not caused by climate change. Scientists are not arguing that, and I'm a climate scientist by training, but are increasingly influenced by climate change. One of the consequences is we have communities in the Central Valley of California that still don't have access to safe water and sanitation. And during the drought, as groundwater levels have dropped, some of those community wells have dried up. The groundwater levels have dropped below the level of the groundwater pumps. Those communities now have to have water trucked in. There's a direct public health concern associated with that, especially, not only, but especially during the pandemic. We know that clean water is critically important for maintaining public health. During the pandemic, we all learned again how to wash our hands better. But if you don't have safe water, if you don't have sanitation, if you don't have enough water for day-to-day needs, then the consequences of these kinds of pandemics are much worse.
And I can give also, sorry.
Go ahead.
Thank you. Another examples, yes, COVID is all over the world. We know as Peter has just mentioned the fact that we need water. And there are places where people get clean water in their houses. There are places where you don't get clean water in the houses, not only in developing countries, but in poor areas in developed countries. So if you are at home and your resources are limited, then the stress is more if you have to go out to get them. And we have, for example, the case of springs in Nepal. They have been drying up because the management at the catchment level has not been the most appropriate. So you have numerous communities which sources of water are very limited. The same happens in Mexico, because we don't see, Mr. Cook was talking about taking decisions at the systems level, which we don't do it. It's not about water, it's about development, it's about decisions. And because we don't manage the catchments in an integrated way, that is just not done, because each sector takes its own decisions, then we are getting less water. Naturally, our populations are increasing, so they are more stressed. And you add a layer of climate change, and you add a layer of COVID. And we have seen this year that the places where there have been floods, people are evacuated, and then you see people who have absolutely nothing. And you think, well, these decisions should have been taken before. They should have been prepared before. It's not for COVID, but certain in terms of water supply, sanitation, and now because floods are increasing in terms of preventive measures.
So I agree with all that, clean water, sanitation. I think, many cities in the developing world are not fully sewered. They do not have enough sanitation. That's something that has to be worked on. And, stormwater infrastructure, right? We have very heavy rain, but a lot of the drainage systems in our cities here are not quite enough. And in fact, some of the cities are actually taking groundwater, right, from the cities, and as a result, the cities sink. So when you sink, your already inadequate stormwater infrastructure gets even worse, and that's why that's why we are getting a lot more flooding in some of these cities. So these are really some of the issues that I think needs to be immediately tackled in many of these cities.
Yeah, right. That's a really good point. And my last question for the panel discussion is that so we know right now we have made great progress in climate and hydrological modeling, but our current predictions of future water-related extreme events, including droughts and floods, still have pretty large uncertainties. And we know the broad trends in terms of how climate change will affect the water cycle at large scales, but we don't know the exact magnitude and the impact of those extreme events at policy relevant scales. And so my question is, how should we utilize those large scale cost resolution climate projections for local scale decision-making processes? And how should we factor climate uncertainties in our decision-making? And do you have any thoughts in terms of how to invest in climate risk information as a public good? Dr. Cecilia, do you want to take that one?
Yes, what you said is very pertinent, because in terms of in the time of climate change, the whole world is worried about carbon, which is important. But if we see water doesn't have the same importance, but this translates, as you have mentioned, in floods and droughts. So how do we use the knowledge? We need more knowledge. We need it to continue working on it, because we don't know with this, even with all this modeling, we don't know how this will translate in my basin. Am I going to have more rainfall, or am I going to have less rainfall? And you talk about policy making. The policy making cannot be done with the type of solutions with the type of science that exists at present. We need more science. There is too much uncertainty.
If I could add some things. First of all, not everything is equally uncertain. I would argue that the climate models are remarkably good and getting better all the time. We know some things with much more confidence than others. There are still uncertainties, and by uncertainties, what scientists mean is there's a range of outcome, not that we don't know anything. We know quite a bit. And I would also make the simple argument that almost all of the things, if not all of the things that I can think of that we want to do to improve the sustainability of water systems, all of the things that I described on the soft path, help us in building resilience against climate change. Anything we can do to meet basic human needs for everyone, anything we can do to expand non-traditional supplies or reduce wasteful use of water or increase demand management, anything we can do to make our institutions more flexible will help us to deal with the challenges that climate change is bringing. So let's think about what we know, let's plan for what we know, let's plan for uncertainty, and let's build more sustainable systems.
Okay, totally agree with both of them. But in fact, for policymakers who have to make hard decisions like, what do I do? The Prime Minister has posed the challenge to us in Singapore, and there are various scenarios of possible impacts on Singapore and for the rest of us, right? Whether how much sea level is going to rise, how extreme is the weather. I had to face this question when I was at PUB, because I had no knowledge of the future. The science wasn't quite developed enough. But as a policymaker, you have to decide, because the media is kind of talking about Orchard River flooding, Orchard Road becoming Orchard River. And what do you do, right? So as policymakers, then you've just got to kind of make the best judgment that you can, come up with good solutions. We created this detention tank under the Botanic Gardens. But I think it is an area where we need a lot of research, and researchers, climate scientists must work very closely with policymakers, come up with new creative approach, right? The traditional engineering approach, where I just design for a certain parameter, may not be adequate, right? We may now have to kind of, as Peter Gleick says, a more adaptable, a more flexible approach. I'm reminded of the Fukushima power plant, right? The engineers in Japan thought, well, I'm going to build this wall that's high enough for the biggest tsunami, you will never overtop that wall, right? But then a big tsunami came along, and the rest is history, right? So it's becoming more challenging, and so we all need to kind of work very closely together, understand there's a lot of uncertainties, the science is evolving, but then we have to kind of creatively find, different ways to be more adaptive, to be more flexible. I think the Dutch has got this system called adaptive management, where they're looking at scenario planning, tipping points. So at NUS Altaris, we are, looking very closely at what they do and trying to kind of learn from them and do our own research as well.
So I have to add 2 points. First of all, I agree completely with that. We cannot let uncertainty prevent us from making decisions. Things will always be somewhat uncertain. We have to learn how to make decisions without perfect knowledge. And in your Fukushima example, there were 2 problems. One was the failure to design the wall high enough, but the other was the decision to put the emergency generators in the basement rather than on the roof. That was an engineering flaw that could have been foreseen, and reminds us that we need to be more thoughtful about resilience in the face of extreme events.
The word is resilience, right? Yeah, you must plan and design for resilience. Yeah,
right.
Not just look at things from a short-term, cost perspective, right? Or functionality perspective, but think of resilience. What if something happens?
Yeah, that's right. We really need to kind of integrate resilience in our future planning processes. And I really appreciate all 3 panelists for the very engaging and informative panel discussions. Okay, now let's move on to the Q&A session. Let me have a look at the mostly voted question. So the question is how to bridge the science policy gap to enhance the climate resilience and water security. Dr. Gleick, do you want to start? Sorry.
So very quickly, a very short answer to that. Professor Hu said this already. We have to bring scientists and policymakers together. It's critically important that when we make decisions about water security, that it's made not just from a narrow institutional point of view, but one that integrates smart science together with the policy. Policymakers need to listen to scientists, and scientists need to be willing to talk to policymakers and be able to talk to policymakers.
Right.
Okay, Cecilia, after you.
I'm sorry, Mr. Ku. And what Peter said is very true. Scientists also have to learn how to put the arguments and how to talk to policymakers with less uncertainty, with more humility, and trying to do more science and taking more practical decisions. Because many times the decisions taken in science are so abstract, so theoretical. And then we go to Mr. Ku and then tell him all those amorphous decisions, and then they are not as useful as they could be.
Okay, let me answer that question with reference to a number of questions that I saw in the Q&A about water and energy, right? Because some of the questions said that, oh, Singapore, you've gone into desalination, new water using membrane technology, and that's very energy intensive. And let me try to clarify that, right? In fact, Peter, I addressed this question partially, and I want to make it a bit clearer. You know, for water, unlike electricity, right, it costs a lot more to move water around, right? Water molecules are much bigger than electrons than it is to purify water, right? So even though, you know, I'm using a more expensive method to purify water, membrane technology, on a per unit cost basis, especially if I'm supplying water to a very dense city, it is actually not very much. And that's my experience from PUB, right? I found that I could get new water or desalinated water when I tended out my plants for very low cost per cubic meter, right? And that's because I had the economies of scale, right? The more expensive part of water is actually trying to move the water. And if you have a very sprawling city of, you know, single family houses, then, you know, that's a lot of money to move that water to supply all those sprawling, you know, dwelling units, right? Yeah. So how do we then, okay, even looking at membrane technology, it still uses a lot of energy, right? How then do we try to lower that energy per cubic meter? And this is where the policy people challenge the scientists. Okay, give me an answer to that problem. So PUB issued a challenge to the research community. Can you reduce by half the amount of energy required using membranes to desalinate water? And it's amazing the number of ideas that are coming out, including borrowing from nature. So that's an example, another example of nature-based solution. All right. In fact, the work is being carried out in our local universities. Look at the kidney, right? Nature does purify water amazingly. The kidney uses a protein called aquaporin. And now our engineers in NTU and NUS, I think, are looking at how do I create aquaporin membranes, because that will reduce the amount of energy required to treat water by more than half. So that's how science policy get together, right? You have a real challenge, a big societal challenge. I think you need a lot of, you know, brilliant scientists to help the policymakers. Okay.
Yeah. Thanks, Professor Koo. Due to time constraint, I think maybe we should just have our last question as a way to close our discussion. Somebody in the audience asked, what are some examples of water conflict events in Southeast Asia? So can you share with us some examples?
Yeah, so very quickly, I would suggest that people who are interested in the water conflict issue could go look at the water conflict chronology. Just search for it, water conflict chronology. It's an open source database. There are thousands of examples there. Some examples of conflicts in Southeast Asia have to do with militants attacking water systems. We, of course, worry, it has not yet been a violent conflict, but we worry about transboundary water issues on the Mekong River, for example, on all the rivers that cross borders in Southeast Asia, where there are no agreements about how to share the management of those shared water resources. You can search in the database by region, you can search by date, and get more specific examples there.
Dr. Cecilia, do you want to add anything?
No. I think that database has a wealth of information.
Okay, great. Professor Koo?
Well, nothing much more to add. I think it's more kind of worrying about potential conflicts rather than current day conflicts. But of course, historically, I'm sure there are lots of conflicts over water in the past.
Okay, yeah. Thanks again. So with that, let me give my closing remarks by summarizing what we have learned today. Let me put up my slide and share my screen with you. So climate crisis is a water crisis. And climate change has already and will further intensify the hydrological cycle. Southeast Asia is particularly vulnerable to global warming associated natural disasters, including rising sea levels, intensified typhoons, disruptive floods, and parching droughts. And transition to freshwater sustainability under climate change requires a soft path water solutions. As Dr. Gleick explained, we need to rethink water supply, rethink water demand, improve institutional management, and integrate climate change in our decision-making processes. And water governance plays an important role to support climate change mitigation and adaptation, to reduce vulnerability and to enhance resilience through poverty and inequity reduction. Political will and determination, community engagement, and policy transparency are crucial to ensure that water-related actions can be implemented on the ground to achieve goals. And the cities bear the brand of climate change impacts on water systems. Livable cities should ensure long-term water sustainability and treat water as an environmental and social asset. Climate resilient planning of urban space requires circular water management, dynamic urban governance, and integrated urban systems approaches. With that, let me bring the session to a close. First of all, I want to thank the HEAD Foundation and the Center for Nature-Based Climate Solutions for organizing this webinar series. I also want to thank our three fantastic panelists, Dr. Peter Gleick, Dr. Cecilia Totahada, and Professor Kuting Chai for the really insightful comments and thoughts, and some really inspiring vision of how to fight climate change to ensure a sustainable, resilient, and just water future. And on behalf of the panelists and organizations, I also want to thank all the audience for the really challenging sets of questions, which help us to think more deeply into many important aspects of climate change and water security issues. And we will continue the climate conversation we've had today, and we will talk more about energy and food security in our future webinars in August and September. So the dates of these webinars will be confirmed in the near future. So please stay tuned. Thanks again, everybody. I really enjoyed the conversation, and I hope you too. I wish you all of a good rest of the day. Take care. Bye-bye.